Get started. So welcome. And I happen to be this person, Mark Smucker. I'm an associate professor in the Department of Management Sciences. I'm also the associate chair for management engineering, and that means basically that I, with the help of many other people, manage the running of the undergraduate program. Our agenda today is I'm going to have a brief introduction, then we're actually going to turn it over to the students. And this is really probably the best way for you to learn the most about management engineering, is to hear it from people who've been experiencing it. So they'll take you through first year co-op, various aspects of life as a management engineering student. They'll get to talk about their fourth year design projects, and also we'll have some Q&A at the end. And please, feel free, anytime you have a question, go ahead, ask it, or be thinking about those questions that you have. We're very happy to answer them. And we'll also hang around afterwards, after the Q&A period, and you can come up and talk to us and ask any questions that you might have, all right? Let's get into this. Management engineering. Well, what you earn, this degree, is a Bachelor of Applied Science. And this is really the distinction and the thing that makes us engineers, okay? Engineers take science, they apply it to actually design and build solutions. So whereas if you were in science, you'd learn all sorts of fascinating things about it, they wouldn't be teaching you how to make things. What we're focused on in management engineering is actually making things. And a definition that I really like comes from a former student. Management engineering is using mathematical models and software to optimize and improve systems. Now, that's about as succinct as we can get, but it's sort of nebulous. But by the end of the presentation, I hope you have a much better understanding about what this means to be able to make these models and implement them in software and so forth. But to give you an overview of the degree, you need to understand that management science really is sort of this nice interdisciplinary mix. We take operations research and analytics. If you want to, it's basically the math component of the program. We take software and information systems. If you don't want to talk about the science, it'd be computer science. And then we also have a component of people and organizations, which would be psychology and economics. And these three areas together form the basis of the program. What's the curriculum? What are the courses? What are you going to take? Basically, all engineering programs have a set of fundamental engineering knowledge that you're going to need to learn. And so in management engineering, we'll have you take courses in chemistry, physics. You'll learn about electric circuits. You'll take thermodynamics, material science. There's a lot of math. You have pre-calculus courses, you have linear algebra, we've got 2 courses in probability and statistics for you, and we even have, yes, 1 more course that you have to take in English and communications. You're not done yet with that. And with all of those things, you can see, well, those are real fundamentals to a career as an engineer, and but then what about the actual focus of the program? So yes, operations research, industrial engineering courses. There are a set of 6 required courses that students take. You start off learning in your second term about work design, facilities planning, basically how to arrange things and improve the functioning of people working on assemblies and other sorts of things. We have optimization, and this is really a core part of the program. So it's building these models. How do we act? So we capture the world, what's happening in the process. We encode it usually in some form of a mathematical model, and then we can apply mathematical optimization to actually improve things. And so this is the first course, and you start to learn about how to optimize things. And then we move into much more of the sort of industrial engineering style courses where you're learning about operations planning, you're going to learn about stochastic models and methods, another optimization course, and supply chain. Okay. Then there's a whole bunch of really great electives that you can take, more optimization, more things dealing with the sort of probabilistic, stochastic nature of decision making, and the way that we can manage and monitor quality in systems, And then finally, scheduling. So how do you actually put together schedules for either order of operations? It could be your class schedules at a university, all sorts of things. This happens to be an extremely challenging problem requiring sophisticated math and algorithms. So the other component, computer science, as well, there are 6 required courses. And this progression is really quite nice. You start off with a computer programming course. Have no fear, the computer programming course has no requirement that you have any sort of high school experience with computer programming. It will start you off from scratch, and you'll basically learn how to program in that first course. The second course continues your programming education and moves you into a deeper understanding of the data structures and algorithms that are used. We next move you on to working with software that will talk and store things with a database. And then finally, you get into software engineering. And now in software engineering, we're going to teach you how to work as a team to build even larger software systems. So as you go through these courses, the software systems get larger and larger that you're capable of building. And so by that time, you need a team to be able to build a system. Then we go into actually perhaps one of the more complex things is actually considering how are we going to interface best with humans. Okay, so human-computer interaction is a very critical part of all these computer systems, and we have a required course on that. And then finally, this Decision Support Systems course. This is actually sort of a combination of the operations research side along with the information systems side. And the idea is that you're able to take that mathematical models and the information systems and combine them together to build systems that managers would actually use to help them make better decisions. And as well, we have all sorts of interesting electives in sort of this information systems area. Data mining, analytics, and user experience, telecommunications or computer networking course, and even a course on search engines. People, organizations, and economics. Again, a set of 4 required courses. You learn, all engineers actually in Canada have an engineering economics course where they learn the fundamentals of money, organizational behavior, how do individuals in an organization function, managerial economics, so more work about economics, more at the management decision-making level, and then organizational design. So this is the broader, not so much the individual, but sort of the team and the organization for how does this work. And there's certainly electives that you can take to learn more about that area. Now, where do you go with all of this? This is a lot of stuff. These are a lot of very sort of, you're like, I can kind of believe that they fit together. And if you want to think about it, so since there's 3 areas, we can't just say, here's like a line, a spectrum from one end to the other. What we want to do is we put it in a triangle here. And what we can do is we can sort of visualize where different careers that students take after they graduate are. So if you're up near operations and research and analytics, you could get a job as an operations research analyst. You're likely to be involved in a company dealing with the supply chain, with the inventory at the company, and all those sorts of things. You could be really far down and really say, I really want to focus on software. And you could actually have a job as an applications developer. Actually, your primary job is to be writing software all the time. You find yourself much more interested in sort of people and businesses and organizations. You could take a role as a management consultant. You'll still be using what you've learned in the other areas, you just have a little bit more focus on the people and organizations. Data scientists, many of our students are taking jobs in this exciting new area. You're going to combine both how to optimize and actually to work with the information systems. And some people, they like the software, but they don't want to be spending all their time actually writing code. They find that they prefer much more sort of a project coordinator, project manager role, and they're taking jobs in software companies in that sort of aspect. And they interface with both the developers, the testers, the marketing, communications, a whole set of people. And so it's a very multifaceted role, and our students do very well in it. And then finally, we are a modernized industrial engineering program. The modernization is largely the addition of the computer side, the information system side, but at our core, it's an industrial engineering program, and certainly we have students who get jobs still doing industrial engineering. Now, I can show you this, but it really should be made real for you, so it's not too hard. I went and I go into LinkedIn and I find our graduates, and these are real people, real photos. Meva, she's a developer in data science and machine learning at Bell Canada, and basically a data scientist. Karen, she's a senior analyst doing supply chain insights for Maple Leaf Foods. Scott Walton, he's an industrial engineer working at basically an aerospace company. His title is Continuous Improvement and Methods Lead. So he's in a factory type situation, and he's always working on how can we make the factory more efficient. Yusuf, coming out of school, went into management consulting. He worked for many years for Deloitte. Then he went back and he earned his MBA at a school in France. I forget which one, but it's very famous. Anyways, and now he's, after earning his MBA, he's working for Strategy Ann, which is a PricewaterhouseCoopers company. Rihanna, she's a director of software delivery. And so she's basically at a company in Toronto, and she's in charge of all of the sort of project leads, the scrum masters at the company for all of the work that's happening there. And then finally, we have Stuart Sullivan, who always had a real draw and sort of a personal talent for software, and he continued to develop that in management engineering, and now he's a software engineer at Google in New York City. And so basically, yes, there's just a huge variety in the careers that are possible. And what you're going to see in the student presentations today is that the students are able to, they go through the program, and through taking co-op, through the courses, they sort of find out, oh, these are sort of the things that I like and I prefer. Some of them stay generalists, but a lot of people do say, no, I think I really like this sort of mathematical modeling aspect a lot more, and I like dealing with industry and manufacturing. We have other people who are like, I want to be in a high-tech software company, I want to work for Facebook, I want to work for Apple. There's doing all sorts of work along those lines, being project managers. And then we've got a whole set of students as well who are like, wow, I really like the more business aspects of things, and I like dealing with people. And no, I want to go into management consulting. So we have a very broad range. It is possible. And through the program, they end up finding out what they want so that by the time they graduate, they can go and get the job, which hopefully will be a job that they really like. But of course, I should always say it's jobs. We do have students who also go on to graduate school, but Waterloo engineering in particular, very much a large majority of the students, because of the co-op program, very focused on, I want to keep going out and working, all right? And so now I will turn it over to the students.
Since we're all going to be up here, I think it's good just to maybe go around and introduce ourselves. So my name is Pallavi.
I'm Rebecca.
Curtis.
Sam. And then we're all 4B management engineering students.
Are we off camera right now? All right. We're going to awkwardly walk in front of this slide and then get started.
Yeah.
I'm going to awkwardly stand in front of my colleagues here to get things started. So like I said, I'm Curtis. To kick things off, I'm just going to tell you a little bit about first year at a really high level, what you can expect, the courses you'll be taking, and sort of the support we have to make things as smooth as possible. And obviously if you're here, you've probably been pretty successful through high school and everything, and I'm sure plenty of people have told you, you know, in university you're going to change your habits, you might see your grades drop, et cetera, et cetera. And if you're anything like me, you're going to get that advice and you're going to completely ignore it, which is the absolute wrong way to approach first year. So hopefully you can learn a little bit from my experience there. But really the point I want to make, both the students and parents, is that first year is a really rocky experience for a lot of people, but it's absolutely not the end-all be-all of future success. So if you do choose to come here and you're feeling stressed about stuff, talk with your family, your friends, your classmates, use the support you have, and try not to worry too much. From an academic perspective, as Professor Smucker went into, you'll be dealing with both general courses and MSci-specific courses. The general courses, again, focus on things like chemistry, linear algebra, calculus, physics. Oftentimes they'll feel like a living nightmare, but if you work with your classmates closely, you'll find a way to get through everything. And then on the management side, you'll be dealing with things like intro to operations research, intro to software design. They really kind of set the groundwork for some of those core management-specific principles that we'll be discussing a little bit more deeply. And like I said, everything does get a little bit challenging, but they do give you a lot of really great resources to make sure you're well taken care of in your first year and to sort of ease that transition. You have WEEF TAs, which are basically upper year students that can help you with some of the nitty-gritty technical questions you may have for any of your courses. Your TAs will run weekly course sessions, so they'll kind of gather your class together, put you all in a room, run through particularly challenging problem sets to help you study for exams, midterms, whatever it may be. And finally, and of course, your profs will all have office hours. So if you really need some information, you can go chat with them, pester them, get everything you need to move forward with any of the problems. And that kind of sums it up for sort of the overview. So now we'll dive into some of our favorite courses.
All right, so I have really enjoyed the operations research courses that I've taken. So I'm going to talk a little bit about MSci 332, which is a course that we take later on. It's like our deterministic optimization models and methods course. So yeah, this was getting further into some of the OR methodologies, and in this course we got to take on projects that tackled real world problems. So this could be like warehousing type problems. So I worked on a bin packing problem that would be useful for warehousing and pallet packing for like a logistics company. Then there were also projects that worked on things like scheduling drone deliveries and optimizing radiation therapy, treatment planning. So lots of different projects that we could take on in different fields that you can really see the impact of. But I've also had a lot of use for this course in other things that I've done. So in some of my other courses, so even in my software engineering course, I used some of the methodology that I used in this course for a project. And I'm currently taking an advanced optimization course. And I'm, again, working on things advanced that I learned in this course. But I'm also a softball coach. And at the end of a season a few years ago, I had to rank all of my players on different skills. And so I asked the league what they do with this information. And so the next year, when they get all of their all of their registration for the year, they use all of this ranking information to help make balanced teams for the next year. They also have to take in considerations like friend requests, coach daughters, things like that, to make teams. But they do this whole process manually. So I'm actually taking on a project right now for my current operations research course to develop a system so that they can input all of this data and come out with teams so that we can reduce a lot of time in people making those decisions manually. Also a note on that, I plan on doing my master's focused on operations research at Waterloo in management science. So I've really enjoyed this side of things.
So the course that I wanted to talk about that was very important for me was MSci 252, which was probability and statistics for engineers. And I chose to approach this presentation by actually starting to try to explain one of the key principles that I found very useful, and then I'll talk about how I applied that in work. So one of the important things that we learn is this idea of statistical significance. And a very common application of this, especially in the tech world, is something called A/B testing, which you may or may not have heard of. So in A/B testing, companies are basically looking to compare two different experiences, so say A and B, and they're trying to see which one is better, maybe which one users prefer. So what do? Well, they take their users and they basically randomly allocate them to one of the two experiences. So let's say half the group goes into A and half the group goes into B. And then they try to understand and measure the behavior of the users. And there's lots of different measures that exist, but one really common one is something called click-through rate. So you can have a click-through rate for A and for B. And so to give a bit more insight into what click-through rate might be, it's what percentage of the people that arrive at experience A actually then perform a particular action. So maybe it's something like clicking the buy now button, right? So that's kind of what we mean when we say click-through rates. So let's say you're in a company, you're running a test like this, and the click-through rate for A is, let's say, 13%, and the click-through rate for B is 10%. Well, does that mean that A is necessarily better than B? Before the stats course, I would have been like, yes, of course, like it's higher than 10%, therefore it's better. But what I learned in stats is that there's this concept of hypothesis testing. So what that means is you start off with a null hypothesis. So we say, let's say that the null hypothesis is that both the rates are the same. So that 10% in both cases, that's the null hypothesis. And if you have a null and that's not true, then you need some sort of alternative. So maybe your alternative is that the click-through rate for A is actually going to be greater than the click-through rate for B. So I have covered some statistics there. I'm going to simplify sort of the rest of this process. So what essentially happens is you use math and you calculate something called a p-value. And that p-value is telling you what is the probability that we would observe 13% and 10% if our null hypothesis, that the two rates were the same, was true. And if you have a really low p-value, what that tells us is that we can reject the null hypothesis. It doesn't mean that we can confirm that our alternative hypothesis is true, but we know that our null is not true. Okay, so probably scared you enough. That was enough of a first year lecture. But the reason that I wanted to explain it is because this is basically what I got to go do in work. So in my fourth and actually fifth co-op as well, I worked in the Bay Area at a company called Tile. And Tile creates Bluetooth-enabled tracking devices. So I know the white doesn't look too great, but these are the four products that they have are part of their product line. So what you do with those is you clip them onto your keys, you put them in your wallet, and then you have a mobile application that essentially lets you track the location of those items. So if you've misplaced your keys, you look on the app and you can find them. And one of the really cool projects that Tile was taking on when I was there for co-op was that they wanted to launch a subscription offering because they wanted some sort of recurring revenue stream. So what I mean by that is they wanted to have software features that they could charge people monthly or annually to have. So one of the features, for example, might be something like, I have this tile for my keys and I want to be able to share it with, say, my friend or my roommate. So one of the things that we did is actually ran A/B tests to determine some of the features of this. And in specific, there were three things that we looked at. So we looked at the price. What price were people willing to pay for this sort of offering? We looked at the length of the free trial. So if we offer people this free for 60 days versus 30 days, do we see any difference in how many people decide to purchase? And we looked at the feature set. If we have 3 features that we really have ready right now, or if we had 7 features which we can have ready in 6 months, does that change if people are going to buy? And so that goes back to the A/B testing that I talked about earlier. So you put this up, you have real users go and interact with this page, and you see how many people actually click to purchase. And based on that, you can see if the results are actually meaningful, statistically significant, and you can then draw conclusions as to what your price should be, what your free trial, or what your feature set should be.
I will not give you a lecture on statistics. The course I will be talking about is MSci 436, Decision Support Systems, which is actually the one Professor Smucker spoke a little bit about before. But I really enjoyed this course, so I wanted to talk more about it. And the title of the course is kind of ethereal. It's hard to get a really good understanding of what that means. So before I dive into it though, I want to set some context, and it's the first line of the slide, which is, making decisions is really hard. And we see that every day in sort of just regular life. Even things that should be really trivial, like picking a restaurant or deciding what to watch on Netflix, take up way more time than they deserve to take up. So it becomes pretty clear that if there's more on the line, millions of dollars at stake, high pressure situation, you probably want something a little bit more rigorous than human judgment to help you figure out what you should do. And that's exactly what MSci 436 focuses on, is teaching you how to build out the tools and models to start at a particular point and get to a particular conclusion. And this kind of looks like if you had a giant set of data, helping you go from that data set to a few alternative solutions to ultimately picking what you're going to end up doing. In kind of simplified terms, it really just helps you go from A to B in a way that you can go back and justify. And this is super, super important because it comes up constantly in job interviews, on the job, over and over. And I'm sure my colleagues here would absolutely agree. And it does this in kind of 3 core ways. The first is this idea of data-driven decision-making, which really is more of a buzz term at this point than anything else, but it comes up all the time, as I said. Having the ability to go from a set of data to a particular actionable decision is an essential skill for all the kind of careers we've described earlier in the presentation, and probably most of the careers that you guys are sort of dreaming of right now. Along with that, it really helps you put the pieces together of management engineering. And this is kind of what Rebecca spoke about before, and it's another great opportunity to do that. It lets you combine some of the pieces of statistics and logistics to build out these really cool models to solve problems that you might not have thought a management engineer would really be involved with solving. And I'll talk a little bit about my final project after this to sort of give some context to that as well. And the final point is it lets you understand why you're doing something. And this is obviously really important in any sort of job scenario, but having the ability to be in an interview or in a job setting and say, like, step by step to your manager why you've arrived to a particular conclusion is so, so important at any stage in your career, but particularly as a co-op where you're still kind of fighting for that credibility among your team, because obviously you can't just walk in and start saying, do X, Y, and Z. So to dive a little bit into my final project, what my team and I were able to build was an interface that allowed local restaurants to optimize their donations to local charities based on the needs of particular charities and the availability of the restaurants. And this is one of those problems that integrates some of the statistics that Pallavi covered, some of the logistics that Rebecca covered, and puts them together in a really cool way that sort of helps you bridge that gap between academia and real-world problems, which is always a really rewarding experience. And it's a mandatory course now, so you don't have a choice. You have to take it.
Okay, so hi everyone, my name is Sam. I'm going to talk to you today about co-op. As you all know, you are going to take 6 internships, totaling over 2 years of work experience. The world is your oyster if you choose Waterloo. Specifically, we have a job portal with over thousands of jobs from hundreds of companies, from hundreds of industries, with hundreds of roles. But specifically, I'm going to talk to you today about why management engineering specifically will launch your career. So as you all know, as Curtis said, we are super data-driven as management engineers. So I'm going to just dive deep into some of the LinkedIn results from our postgraduates, so our management alumni. You'll see here that the top employers, there's a wide distribution of industries. You got your consulting, you got Deloitte, number 1, and number 6, Accenture. You got manufacturing, so PepsiCo and Toyota. You got your big tech companies like Microsoft and Amazon, and you got banking, so financial industries like RBC and Manulife. So you're really not put into this cookie cutter, you're only set up for one industry. There's so many things that you could do. Okay, so we're going to just dive into the most common job titles. It matches up pretty well with the types of industries that you saw on the previous slide. So number 1, consultant. Many of our management engineering alumni are working at Deloitte as consultants, or PwC. You have your business analysts. These are very data-driven roles. Their main role is to provide a lot of graphs, a lot of actionable insights to provide to executives in many companies. And you have your product manager, which is also within the information systems pathway of management engineering. As you can see, on the more OR side, you have supply chain analyst and manufacturing engineer, so number 6 and number 9. Okay, so I'm just going to deep dive into my own personal experience. I've done 4 internships in the software world, 3 specifically as a product manager. So product management was number 3 on the previous slide. Does anyone have any idea what product management is, or even just a vague understanding? Yes, okay.
I'm giving a guess, but I think it's where you're taking in the needs of a consumer, or a customer, I mean. And as a person that has knowledge in business and in software, you understand what's feasible and what's not, and then you outline what the needs are, and you plan it out and give it on to the developers.
Yeah, that's a perfect description of what it was. Yes, you're working with engineers, you're working with designers, you're working with marketing, and you're working with sales, all to answer a few questions like what? Number 1, what are we going to build next? Number 2, why is it going to be impactful for the company that you're working at? And number 3, why is it going to be impactful for all the users that use your product? So as a product manager, you are super caring about your product and the people who use it. Across my internships, I've got to work on these 3 products. The first of which was eDevices. I specifically targeted this company in Toronto who make e-readers and audiobooks and everything having to do with reading because I like to read. It was a company called Rakuten Kobo. What I got to do there was actually work with the hardware, see how it was built, and how it was marketed to our users. Number 2, I worked at a mobile gaming studio in Toronto called Yukon Games. Mobile gaming is a $70 billion industry. It is humongous. I got to work on casino games, so it's a lot of behavior analytics of why people buy something, why people choose to spend on something which they'll get no actual value from. So why people gamble, right? It's a very challenging, interesting topic. And I got to work with game designers and artists just to develop some of those games. And it was a ton of data too, so management engineering really helps with that, with the data analytics sector.
And lastly, my last co-op was in financial tech. It was a company called Credit Karma in the Bay Area, and what they do is they specialize in credit cards, personal loans, auto loans, mortgages, taxes, all the fun stuff that you probably have no idea about, but that you're eventually going to need to know. So working on a product like that was a lot of exposure, but good as someone who needs a lot of that information after graduating. Next slide. Okay, so I'm just going to talk about how did management engineering give me a competitive advantage over, say, software engineering or any other program at any other school. So number one, it is highly collaborative. Some terms you'll have 5 group projects. You're being forced to work with your classmates. You'll understand what motivates them, what challenges them, and how to build something just really, really awesome. And that's important because, especially in my role, I have to work with a variety of different people with a variety of different technical aptitudes. Sometimes I'll have to explain one thing in layman's terms, sometimes I'll have to be highly technical. So being able to be highly collaborative and a team player is super important. Number 2, that goes into technical knowledge. We do such a diverse number of courses, as you saw from Professor Smucker's slides. So from information systems, like knowing how a database works, to optimization, so a lot of statistical analysis. So you'll be able to talk to engineers, you'll be able to talk to marketing about a technical concept. And number 3 is a diverse skill set. You'll hear a lot of times that people say, oh, management engineers, jack of all trades, and it's a really negative connotation towards that, but what it actually means is that you're able to market yourself in 100 different ways, just because we have such a breadth of courses and so much experience in all of these courses. So it really gives you a competitive advantage. All of us up here have at least had one of those roles, so feel free to ask us any questions.
Yeah, so on that diversity, I've actually taken 3 different paths on co-op. So my first 2 co-ops, I worked in project management roles. My second 2 co-ops, I worked in industrial engineering type roles. And my last 2 co-ops, I worked on software type roles. But I'm going to talk to you about my industrial engineering experience because those were my favorite and gives you a different side of things. So I got to work at UPS Supply Chain Solutions. I was working on continuous improvement projects in their warehousing. So that could be things like changing the order of their operations to decrease the amount of time that it took to complete a task. Or I was working on a client implementation, so I had to figure out what the racking spacing should be so that we could use as little space as possible but still get all of their product in shelving. So it was really cool getting to work with other industrial engineers and also other management engineers that had graduated from our program and were working there, and really apply things directly from class on co-op, which was a really nice experience. The second co-op that I worked in the industrial engineering space was more on the manufacturing side. So I worked for a company that manufactures canopies. And I was actually the first person that they brought in to look at how to improve their processes. So they had done a lot on improving their product, but I was the first person that they brought in to focus on process and how to increase their capacity and output. So I was focused on researching machines to automate their solutions. So I got to present to the CEO of the company on what machines that cost hundreds of thousands of dollars they should invest in to automate their production. And then they were also in the process of getting a new building. So I got to design the facility layout for that new building with the new machines that I had proposed that they invest in. So that was really cool. And then I also worked on some other small projects like changing the order of the parts so that it would flow linearly throughout the process and updating order forms. And I got to work both with like the production side of things and the engineering team, and it's important to be able to bridge that gap. So that's the end of our formal presentation. Oh, sorry. No, my other slide is the end of our presentation.
That is the end of us talking about courses and co-op, which are all super important and a very big part of the Waterloo experience. But I think something that's been very defining to me has been really the management engineering community that we have here, and that's something that I wanted to take a couple of minutes to talk to you all about. There are a lot of opportunities for you to get involved in Waterloo in general, but there's also some really cool ones that are a bit more specific to the department. So the Institute of Industrial and Systems Engineers, for example, is the world's largest professional organization that's dedicated to supporting the industrial engineering profession. And the University of Waterloo chapter really tries to help its students develop academically, professionally, and socially through different events and an annual conference that they run as well. The Industry 4.0 team here is really trying to represent management engineering at UW. And what they're doing is actually designing and then running a Industry 4.0 themed case competition for high school students nationally. So really trying to get the word out there about management engineering and the types of material that we study. We also have the opportunity to complete undergraduate research assistantships. So what that means is that you can apply for a term to work with a professor, do some research, and see if it's for you. And what's really cool is with management engineering being very diverse, as we've all touched upon, there's a lot of different areas and projects for you to work on. And the last thing is, as with other students in the faculty of engineering, but also at UW, there are opportunities to go on exchange as well. So personally, I spent 2 years working as the co-president for IASC. I did 2 undergraduate research assistantships, one in human-computer interaction and one in optimization, and I even spent 4 months studying abroad in Finland. So I think there's a ton of different opportunities out here for you to really get involved, give back to the department, and grow with your class. Which brings me to class community. So this is a picture of our class, I think, one of our summer terms. So because it is a small class size and because you're basically taking the same classes as everyone else for the most part 4 or 5 years, your cohort turns into your family. And to me, this has been something that's really important to my experience. I think if I didn't have a class of now 60 people around me that really wanted to see me do well, as we wanted to see each other sort of like grow through this process, and to support me not only academically, but also just in my life, I don't think I would have turned into the person that I am today or nearly half as enjoyed the experience that I've had. And so because we spend so much time together, slowly you start to do pretty much everything together. So from playing sports together on intramural teams, to going to conferences. So this was actually us at the IASC conference that I mentioned earlier out in Dalhousie, to doing spirit days and dressing up because why not? So most recently getting our iron rings as 4B students. You end up spending a lot of time with the class, and I think it's really great to have such a nice community. But that community extends beyond just the 60 or however many people in your cohort. And I think it's really a community in this department. So one of the big things is that all the different classes also have good relationships with each other. And generally the upper years are really there to help the younger years through. So whether that means holding a resume critique workshop or really just being available to chat about co-op, about courses, or whatever it is you need to succeed, the upper years are really here to try to help everyone get through this program successfully. Also, we have a very, I would say, small department in comparison to some other programs, and because of that, the professors actually know us. Like, I'm pretty sure all the management engineering professors that I've had have known me by name, and they really care to see us succeed. So someone mentioned earlier about having office hours, so even like hanging back after class to answer any questions you might have. I think there's a really strong tie with the department and the faculty here that I think makes it such a positive learning experience. And because of that, the professors and TAs are always willing to help out. They're always willing to take the time, whether that is helping you succeed academically or sometimes even just chatting with you about your career or about grad school decisions or where you see your life going in the future. Like, they're always happy to help, and I think that that community is such a great support to have. So the next thing that we want to talk about, and this is actually the last thing, is our fourth year design projects. So all undergraduate engineering students here at Waterloo have to complete what's called a capstone project. So essentially, it's a chance for you to put to use everything that you've learned over the last 5 years. And since we have 4B students, we thought it would be really cool to just give you a very quick pitch or introduction as to what we're building. So you have some idea of the kinds of problems that you might be able to tackle with this academic background. And then of course, if you have more questions about those things after, we're more than happy to take them. I've done a lot of talking, but I think I'm first. So have you ever returned something that you bought online because it just didn't fit you well? If so, you've contributed to the $40 billion worth of apparel and footwear returns that happen each year. My team, Trendy, is trying to bring mobile streaming to fashion commerce, and we're aiming to create a new shopping experience that combines the convenience of online shopping with the information that you get from physically trying on products. So users of our application can watch posts with similar body measurements to their own, actually try on and discuss different apparel items. And ideally, those users then can vicariously get the feedback that they need to make informed purchase decisions.
Okay, so my team is working with a client called TJX Canada. They are Winners, HomeSense, and Marshalls. They are known as an off-price retailer. Off-price retailers usually have a mandate which they have to prove compliance for. So if you're wondering why Winners is so cheap, it's that they market that they have to be 20 to 60% off of their competitor products. And if they don't, they are at risk of being sued for millions or billions of dollars. So we have built Comper, which is a merchandise compliance software, which allows them to completely streamline their processes for creating reports for audits. And what it does is, part one, you're able to collect information about your products, both manually for non-branded products and both through scraping and automated solutions through the web for non-branded products. So, yes. I don't pitch like my teammates.
So for the first time in history, less than 50% of adults read literature for pleasure. But 80% of them are going to tell you that they want to read more. And why is this? Well, stories are social, but books are lonely. And that's why Caravan is making reading social. The Caravan mobile app is a social reading companion that allows you to connect more deeply with the stories you love, and now with your fellow readers as well. And feel free to ask questions afterwards.
All right, so my project, Max Rewards, is maximizing credit card rewards. So in 2016, 72% of Canadians owned at least one credit card that earned some sort of rewards, but most people don't really understand how these rewards fully work or how to make decisions to use these cards effectively. So what we're doing is coming up with a solution to help users decide which credit card to use on their transactions. So when cards earn points in different ways, there are certain transactions that might be better spent on one credit card than another. So what we do is we provide point of purchase recommendations to our users and tell them for each purchase that they're making what credit card they should use. So this is just a sample of 2 credit cards that earn cash back in different ways, and each of these cards have different limits. So depending on how you spend throughout a month, so how much you spend on certain categories, and how consistent your spending is, we would recommend to you which card you should use for each transaction. So that concludes our formal presentation. So now we'd be happy to answer any questions that you have. And we'll be sticking around after if you want to talk more personally with us. And also just wanted to note that these booklets contain information about all of the 4th year design projects for our class this year, and our design symposium will be in just a couple of weeks. Thank you.
Students are very happy to take any questions that you may have. Please, anything. Actually, anything that you're interested in. Yes.
For the students, I'm just curious, your first year, what were your biggest stressors? Was it time management? Was it course load? Was it just being away from home?
Yeah, I think that's a great question. Okay, to start, yeah. I honestly fundamentally believe that time management is the most important skill to getting through this degree. At least that's how I feel. Like we talked about, the academic support is really there for you. What's overwhelming is the fact that you're taking 5 courses, there's weekly assignments, there's midterms, there's finals, like everything's just going on, and you really need to find a way to balance that. So I thought I was good at that coming in. I think I've gotten better over the 5 years. I think I've learned how to learn and how to maximize the output or return on the time that I invest. But I definitely think it's an important skill, and everyone has their own way of managing their time. I live by my calendar. Some people hate calendars. But I think it is worth kind of investing time into figuring out what time management strategies work best for you so that you're able to feel a little less overwhelmed with all the content that's going on.
Yeah, I mean, I think for me, one of the best things for getting through first year was just like the network of people that I made in my class, because if you are doing it alone, you're not going to be able to get through it. I think it's so important to like be able to work through problems with people and get feedback, because it's not like the way that you get feedback, I think, is different from high school. So having a group of people that you can work with and also just feel your pain. Like you're not the only one going through it. First year's tough and everyone feels that way.
And to note, by the way, the other students also answer, but something that facilitates that is the fact that it's a cohort system. And so the students come in and they'll have all their classes with the same set of students. They'll all be the management engineering students. And so from class to class, they'll all be experiencing the same thing, the same group of people. So it helps build the relationships a lot faster and the connections. Sam? Curtis? Oh, okay. All right. Other questions? Yes.
Do you guys have like a set number of seats, or is it independent?
So how many people do we admit?
Yeah.
Basically, we aim to admit about 85 students. And so that's roughly what we send to the admissions people and say, please try to find the best 85 who will accept and get them here. And that's basically what we shoot for, yes. And we've had more and less over the years, so it's not a perfect science how you get the right exact number of people involved, but that's around the class size that we aim for now. Yes.
How many people are approximately in a cohort?
So your cohort is in,
Now it's 60.
but right at 60. The one we just did, so the students who are first year students in the winter term here, their cohort is running at like 89, 90 right now. A few too many people accepted the offers of admission, and so we got a few too many. But so that's the class sizes have gone up over the years. The very first cohort 10 years ago ended up with about only 40 students in it. But so as the years have gone on, they've gotten larger and larger as the program has grown. Yes.
Do you guys recommend any like certain, like I've taken economics at school. Is there any other courses which you guys sort of recommend that are like electives that would be helpful to this program?
I think that's best answered by you guys.
So one thing that I've found is that often, specifically like on co-ops especially, often the courses that you find aren't as challenging are the ones that I find more useful. Like, I never use calculus in work. That being said, it's obviously really important to get through the program, but for me, one of the most valuable courses that I took was mathematics of data management, which I think a lot of people in high school are like, oh, it's such a bird course, like, or relative to the math courses at least. But I think it has been so useful on so many courses because we learn matrix manipulation. It's an intro to, like, sorry?
Is that like intro to the knowledge?
Yeah, intro to the knowledge, like data management, data science. Like there was a lot of things in that course that I think they just like introduce you to it. So you don't go too in depth, but I think that was super useful.
Does that help you through like first year?
Oh yeah, matrix manipulation. That was that was great.
I mean, I took computer science in grade 11 and grade 12. As we've mentioned before, they teach the first year programming course like you don't have any experience, so you are 100% okay to not have it. Do I think it helped me and made that course a little bit easier? Yes. So if you have the space, you're remotely interested in it, I think that could be useful.
I mean, my general feeling on high school preparation is that you should take the courses that you find interesting, that you need, that are required, and things along those lines. And all of it is good, but the reality is when you hit a university, even if you're like, I did all this calculus, or I took the data course, you're going to find that things move very quickly, very fast, and you're going to realize that what you had before was a small amount compared to the amount of material that you'll cover quickly in a term here.